Hello again, this is Joseph. This is a continuing tutorial of a schematic teaching video that I made previously, and this will be a continuation part 2. It's very important first to always know, and I get emails about this, always know the symbols first before you start attacking overall the schematic. And I'm going to go into detail, very fine detail, on this schematic that I made a video on before. And before that, happy holidays, happy new year. Hope this will be a year of prosperity to all. Now, if you look at the symbols that I had previously, the ones that always come up and are very popular are always the ones that connectors for male, for female, with the pin number. C1 is the connector, and C3, obviously the battery terminal. Obviously, this is an alternator. The fuse, obviously. Fusible link, which is sometimes noted by a different symbol. Clock spring, which is a rotary device located in your steering wheel, which goes bad. Very, very, very popular. Which is for the horn circuits that we talked about. Which is for the airbag system. It allows you to turn the steering wheel without interrupting the electrical connectors and systems of the airbag and the horns, so you can turn the steering wheel. This is the clock spring. You see, it's a circle, meaning you could turn the steering wheel. Doesn't affect the electrical part of the circuits for ABS module, airbag module, and for the horn circuits. Again, this is a ground, which we'll be talking about. So all these things will appear in the circuit today. This is why I introduced this. Open switch is the one in rest position, means it's open. When we activate it, it'll close from here to here. Again, the same thing. This one is closed. See, the circuit goes here, and when we activate it, it'll open. It'll flip this way. This is the one we're going to concentrate on. These two are ganged together. Meaning, when this goes in this position, this isn't the same in this position. I call these always the Siamese twins. When this goes in this position, this goes in this position simultaneously. Now, the other one that I talked about was also over here. This is not an antenna. Someone asked me, is this a... Antenna is a different one. The symbol for an antenna is this one. Okay, this one means there's another continuation of the schematic somewhere else. Part A, then you look for the other part of schematic, which will be A somewhere else. If it's B, then you look for somewhere else that it says B, and so on. This is a splice. The connections, one part to another part of a circuit. A 1-speed motor, and here is 2-speed motors. Reversible motor can mean bidirectional, it goes both ways. Now let's start at the schematic. Where do you start first? And this is a question that I always focus on because it's a little confusing to the viewers. We're going to delve into how to understand a schematic. So we can start from here. The basics. If you're troubleshooting, which we'll do later on, we're going to focus on main components. So if there's a headlight problem, I'm going to go to the headlights, look over here for the headlamps, and work my way back up. If I think I have a problem with a daytime running light module, I'm going to focus on this module. Go over here and see what this is connected to, and go over here and see where my B plus, my 12 volts is coming. So I'm going to back probe over here. Depends what you're looking for and what you're troubleshooting. That's the starting point, the part of origin. Now, start from the basics again. There's a battery over here, 12 volts. Again, it doesn't have to tell you the ground. It's understood there is a ground. So the battery voltage is 12 volts with no alternator working. When the alternator is working, obviously, maybe it's 14 volts, 13.6. Really irrelevant. The most important thing is we're dealing with 12 volts. So 12 volts, one side of the battery, the positive, is connected. There's a connection to one side of a fuse. That fuse over here, called number 41, is 80 amps. Big fuse. That's a lot of ampage. I put a star over here to indicate these are very important details and components to pay attention to. Now we notice one thing. 80 amps goes, right? If the circuit requires 80 amps, it'll draw 80 amps. The other side of fuse 41 is connected to two other fuses. Connected to 42, fuse 42, and connected at the same time to fuse 48. One is 40 amps, one is 30 amps. So, the question that was asked, which fuse will blow first? As somebody, I believe someone asked previously in the video. Before we answer that question, let's finish a little more detail. You notice I put over here 12 volts, a circle. That means the voltage. However, one side of this fuse, this big fuse, 80 amps, goes to 42, number 42, 40 amp, and the same side of this fuse also goes to 30 amps. Over here, the other side of this number 42 fuse, 40 amp fuse, goes to white-black, has a connection to a wire, white-black. Now usually, the general is white is usually the base color. The black, the second one, is usually the stripe. Usually that's the way it is. But of course, make and models differ, and they could have the opposite or whatever, but as long as you're looking for white and black, black would be the stripe, white would be the base color. Again, depends on the make and model. I put a star here. This is very important. Why? Because this white and black goes to a splice, and then now it becomes only a white. So you have to pay attention to these things. Sometimes the color, they change the color on you. You might still be looking for white and black, and you'll say, where's white and black? No, it changed. It went from white and black to white after the splice. Fine. Then it goes to an ignition switch. Okay? The ignition switch, obviously, in battery, and when we crank it, IG2, we're closing the circuit. Remember, we need a closed path for current to flow, and I always teach current, not voltage. Voltage is present in a battery, whether it's connected or not. The outlet in your home has 120 volts. If you do not connect any appliance to that 120 volt outlet, you still measure 120 volts. Are you pulling current if you have no appliance? You're not. The only time you're pulling current is when you have an appliance or a load connected to the outlet. That's why I always stress, put an ammeter to measure the alternator, not just look at the 14 volts. Put an ammeter that I did a video on to measure how much current you are drawing from an alternator. On that big thick red wire that says BAT, put an amp probe. And of course, I always like to put the fan blower, because that draws a lot of current, 20 to 30 amps. When you have it at high speed, you get full voltage and much current. And I like to put the lights on and the fan blower, like I said, and all the accessories on. Let's go to the next point. Now, how much will it take to blow these fuses? The question was introduced. If I have 80 amps, that means if I have 90 amps, this will blow. Not these. This will blow first. So 90 amps, I'll go over here. How much will I measure on this side? I'll measure 12 volts here, and when I put my meter to the other side of the fuse, I'll measure 0. Why? Because this is open. It's like nothing is in between. No jumper, nothing. No wire. Therefore, this is not connected to battery. So 12 volts here and 0 volts, boom, I have a problem across this fuse. How much would it take to blow these fuses? Well, if this is 40 amps and this is 30 amps, let's say 35 amps. If I have 35 amps, and you have to ask yourself, which circuit am I dealing with? There's 35 amps here in this circuit, Remember, there are two paths. One path here, one path here. If I am drawing or pulling 35 amps, I will blow this one. I will not blow this one because the short is in this part of the circuit. Will I blow this one if I have 35 amps? No, this is rated at 80 amps. Let's say I'm drawing 45 amps. Which one will blow? It depends where the short is. If I'm pulling 45 amps in this circuit over here, because let's say there's a module over here. We'll explain the daytime running lights. Let's say there's a problem with the module. I trace it back, and guess where it goes? It goes over here. 45 amps. This will blow. Okay? It depends where the short is in. 45 can blow this one. 45 amps can blow this one. However, you have to look where the short is. If this is blown, that means the short is here. It'll blow this one. If the short is in this one, it'll blow this one. So it depends which branch of the circuit the short is in. But 45 will not blow this one. Again, 45 can blow this one, 45 amps can blow this one. However, depends where the circuit, where the short is. Now, let's continue. And again, thanks for subscribing to my channel, Joe Electronic Schematics by Auto, and the other one, Automotive Electronic Schematics by Joseph. As you can see, it takes a lot of detail and analyzation research to do these educational schematics. So please, my new year, I hope I get monetized. It would be great. So please subscribe and please watch these videos. Now, again, a white wire here. The other side of fuse number 48, the 30 amp, is a white wire. Go over here. Now there's a connection here. There's a connection here. Which one do we follow? Well, we can follow all of them because we're trying to understand how to figure out schematics, how to read schematics. Now, since we're dealing with lighting systems, we expect to see lights, bulbs, modules, switches, fuses. What we don't have here is relays. You will always see relays in fuel pumps, anything, air conditioning, anything. There are relays, obviously, all over in GMs. This is just an educational schematic that I picked. There are relays all over. You have to know how relays work, which I did many videos on. Relay, one side goes to B+, the other one goes to ground. The computer can give that relay a ground, usually. Now, why did I bring up that point? Let's look. A connection here, a connection. You notice both white and white. But you have this. When you see a square like this, that means this is usually like a module. And like combination light switch, usually like Toyotas and things like that have these type of things. It is in a module or in a unit. That's why there is a square around it. This is, as you see this, relay box. Usually it's a unit. It's a square. That means all of these are in a unit. Okay? This is a module. It's a square box, but there's also little circles. Little circles, usually there are pins and numbers. Not in this schematic, but there are pin and numbers, so you know which one it's referring to. Okay? As you see over here also, there is over here, this is like a sensor. Pin 1, pin 2, pin 3. Also a square box around it. It could be in a single unit. As you see over here, the fuse box, the relay box is in a unit, a square box. That means everything is together. Everything is together. The switches, all these things are together. All these things are together. All these things are together. What's prone to go bad? Usually modules. The more electronic components you have, the more you'll have a failure rate, a higher failure rate, like in modules. Sometimes switches, whatever you switch on and off, also are prone to failure rate. Let's continue. We came over here. Let's choose this path. We came over here to this B2 of this, let's say, module or unit, a switch, light switch. This is the important detail. This, like we said before, when you see the dotted line, that means they are ganged together. Remember, I used the terminology Siamese twins. That means when this part of the switch is switched, this one, and I labeled it to make it easier. I called this one 1, this one 2, this one 3. 1, 2, 3, 1, 2, 3. Whenever I put this part of the switch to, let's say, terminal 1, that means this will go to terminal 1, this will go to terminal 1, all at the same time. When I put this to switch to terminal 2, this will go to terminal 2, this will go to terminal 2. When I put this to terminal 3, this will go to terminal 3, this will go to terminal 3 simultaneously, together at the same time. This could be one switch, it could be S1A, S1B, S1C, whatever. It could be a different switches. They are ganged together, meaning that they are operated simultaneously. Now, you have to ask yourself the question, when I close the switch, I'm activating the circuit. How do I know which terminal over here is activating the circuit? That's a question that was asked to me. You look at the terminal and you see if there's a connection. For example, when this is in position 1, this is 1, this is 1, this is 1. They're all in position 1. There is no line, there is no connection here. Right? There is no connection here. There is no connection here. Why is that? Because you're in the off position. Off, off. When you're in terminal 2, position 2, you have a connection for this one. However, there is no connection here. There is no connection here. The connection that you have, and that's why I brought up this point, going over here to 2, when you put the switch in 2, position 2, you have a connection. Here is the connection that I highlighted in red. But not here, not here. So therefore, when you put this in terminal 2, you are activating current flows, follow the arrows, to a red and green, actually out of B1, the connector, the pin, to two fuses. And what are the fuses? Parking lights, tail lights, license plate lights. This branch goes to these circuits: the parking lights, tail lights, license, dash lights, brightness controller. It goes to this. So this is responsible for the parking lights, among other things, right? To 2 fuses. Notice it's getting less. The fuse ampage is getting less. We went from 80, 40, 30, getting less and less, getting to 7.5, 7.4. That means these bulbs or the dash is not really drawing that much current, right? The combination of both of these circuits, the module, the lights, right? And all these things, all these other things, these other headlamps that you'll see cannot draw more than 80 amps. So therefore, this, in this 2 position, when this is in 2, this part of the switch will activate the parking lamps and the dash lights. That's how you figure out what a switch does. Now, 3, position 3. So we did this branch. We took care of this branch and we said current will flow from the white one to this white one through this switch, come out the other side of the switch to a red and green wire, to a fuse, number 32, number 30, the current will divide. Okay? How much current will divide? Has to be less than 7.5. Maybe it's 6 amps, maybe it's 5 amps, we don't know. So red and black. And what is this? Remember I showed you the This is not an antenna. This is another part of a circuit. So if the other part of the circuit would be C, we go look up the other part of the schematic where it says C. That means it's a continuation. We don't want to put too many lines, so we just cut it short and we denote it with a triangle like this. That means it's understood. It's continued on another part of the schematic. Now here's the difficult part. Position 3. If I put this in position 3, I also have a connection. If I put this in connection, again, at the same time, this will also go to pin 3. I also have a connection through a red wire out of B4. A red wire, follow it, and guess where I'm going to? Daytime running lights control unit, a module. Nice. So therefore, this will give B+, this will give 12 volts to this module from this terminal of the switch. Also, when I put this on terminal 3, and I put this one also on pin 3, remember? Simultaneously. What does that accomplish? That accomplishes me a bunch of things. First of all, I'm still giving current to the parking lamps and the dash lights. The parking lights will still be on. But what I did when I put this, I put the switch in this position in 3, I also activated the daytime running lights to give it B+. What else did I do? Through the white wire, through B6, through here. Now this is also, all of these are in 3, position 3. Current can flow here, right? Current can flow here. Now, depending on where this is, they call it a dimmer, but that's a bad terminology. It's not really a dimmer. Either you're putting in a high beam or low beam. The dimmer would be probably over here where it says brightness controller, dash lights. That would be probably a dimmer. Very bad wording terminology. But again, this is just schematic to teach students. So we go over here. Current will flow here, will flow here, will flow here.